We're going to discuss our simplest problem. Fredrik?
Yes, so problem K was the problem that was solved first, so therefore we decided to present it first. So please, Tommy, can you explain what this problem is about?
Sure. Next slide, please. So the problem is about covering a building with cameras. So imagine we have a building, for example, such as on the display here, a convex polygon with a number of walls. And so we are now given a number of camera positions, and we want to sort of cover the whole building. So selecting a number of walls.
Fredrik?
And so, no, please, go back. Yes, of course. So, what we are actually given are not the convex polygon and the camera positions. Since the polygon is convex, we only get intervals of which walls are covered, and the number of walls could be from 3 to 1 million, and the camera positions from 1 to 1 million. So let me just try to illustrate what we have here. So the first sample test case, so I want to draw on this one. Says that we actually have one camera covering 3 walls here, and then these 2 walls. So obviously we cannot choose camera positions to cover the whole building. Now the second sample test case actually has a camera at an infinite distance over here somewhere. So this will actually cover the whole of this region. So now we can actually choose 2 camera positions. Right. And this sort of arc segment I drew here sort of hints at what the problem really is. It's about covering a circle with arc segments. So this is a fairly well-known problem. I found a paper from 30 years ago actually solving this in n log n time. So what you can actually do, if we go to the next slide, so one first thought is that you could do this greedily. So you pick the longest segment and then you just add segments greedily. But as can be seen by this picture, this is actually not possible. You could end up with 1 segment too many, but this is actually a very interesting property of this problem. So either if you are on the minimum cover, the greedy solution will be optimal, you will find optimal solution, or you could, if you're not on this minimal cover, you could end up with 1 segment too many. So what you can start doing is just grab 1 segment, if you have sorted them first, get a greedy solution, and then refine it. So that's, we actually been seeing some of those kinds of solutions now, a bit later into the competition. So the first ones actually do an n log n solution, a bit more straightforward for the teams, I would guess. This type of problem is, it's very common. There's a lot of problems that look like this, for example, with the circular arc graphs and coverings of those. So many teams would have seen something similar.
Thank you.
Okay.
Thank you.
Follow the 2014 World Finals at icpcnews.com and be sure to check out My ICPC.